Ryan, do you want to go next?
Yes, thank you. So my name is Ryan Melsert from American Battery Technology Company. So this is an especially appropriate conference for us. So we have two different business units. We have developed an integrated system for the recycling of lithium-ion batteries. We're currently building our first pre-commercial facility. And independently, we also own large amounts of land and mining leases throughout Nevada, where we are working to extract lithium and other battery metals. So having both the battery recycling group and the primary metal group really helps us contribute to addressing each of these global challenges separately. I mean, the topic today is how the secondary market can contribute to really meeting the near-term demand. And battery recycling can be much quicker to market. Large amounts of feed material already prepared to be going through these processes. It can contribute meaningful amounts in the near term, but ultimately it really is limited by the quantity of material coming back from end of life, from manufacturing defects, from other types of feed material. And by balancing the recycling system with the primary extraction, we get both the quick speed to market as well as the much larger throughput once our primary facilities are operational as well.
Name is Dawei. I'm the VP for Asia for Lifecycle. I just joined 2 months ago. Came from Albemarle. I was running the battery grade carbonate business for them back then. So I'm fairly new in this space. Very excited to be here. So Lifecycle, we have announced. Okay, there's a slide. So maybe go to the next slide, please. So just really quickly, a roadmap about our company. So we have built 2 spokes, and I'm going to go into what that means. And we're running one in Kingston, Canada, and one in Rochester, New York. Each of them are treating 5,000 metric ton per year battery processing capacity. We have announced a new spoke in Arizona, which will become online next year. And we have also announced another spoke in Alabama, which is not on the slide, but that will be up and running next year as well. We are building in the process of building our hub in Rochester, New York, which will be coming online in early 2023. So globally, we are also in the process of expanding in both Asia Pacific and also in Europe to put our spokes and the hub assets around the world to help recycle the battery materials. Next slide, please. So this is just a very brief overview of our spoke and hub technology. Spoke, as you can see from the left side of the chart, we receive the batteries, and there's no sorting that's needed. We can take all kinds of lithium-ion batteries to recycle in our process. There's very minimal dismantling that's needed. It's a fairly automated process. We don't have to discharge a battery, so it's primarily a mechanical shredding process. The hub technology is essentially a hydrometallurgical reaction process. It's a chemical process. We recover the battery-grade chemicals such as nickel, cobalt, and lithium. It's not a very high heat thermal processing, and there's no loss of compounds. Next slide, please. I mean, this is just essentially the same slide where it talks about we are going to get all kinds of batteries from the 3C products, from power tools, from Yves, and we use the spoke process to produce a black mass, which is an intermediate that feeds into the back-end hub process. We have, as I said just now, we have announced the 4 spokes through the North America, and we're going to build our first hub in Rochester, New York. Next slide, please. Just really quickly on the features of the spoke process. There's no wastewater. There's very limited air emission and no fluorine air emissions. We are able to take the full modules fully charged right now. We are developing a process where we can processing of the full packs. Next slide, please. And the hub process in general, it's a hydrometallurgical process, a wet process. The operating temperature range is about 100 to 110 degrees C. We recover battery-grade nickel sulfate, cobalt sulfate, and also lithium carbonate. Very minimal solid waste for disposal. And again, the air emission is low impact. There's no fluorine air emissions as well. That's Lifecycle in a nutshell.
I've had the opportunity to work on a lot of recycling projects over really the past year. It's interesting the way companies sort of look at it. From the first, it's going to become a big market someday. It isn't yet. Cars last 10 years, and 10 years ago, the world produced about 100,000 vehicles, so need 6 million vehicles, so the math doesn't work. However, what's been really interesting is, one, there's a recycling opportunity for phone batteries, computer batteries. Cell plants have incredibly high reject rates. That's another opportunity. We've had some massive recalls in the marketplace, big opportunities. And all the OEMs are pretty much going to be responsible for recycling, and so they need to line up people today, even though the huge demand may not be for tomorrow. From a commercial standpoint, Yves, I know you have a deal with Hyundai Canada. How have you looked at your commercial strategy in order to find the material to put through your plants, and how will you find that material going forward?
Thanks, Ken. Good question here. I think our commercial strategy there revolves around having a relationship with all the OEMs, and at the same time there, the cell manufacturing plants, and at the same time there on the other end, even at the PCAM and CAM level there, you have some rejects to be recycled. So the idea here with the demo plant is that we can take full-size packs, we can analyze it, how much it costs to recycle, what the value we can extract, and then enter into commercial discussions and time that with our commercial deployment. So that's in a nutshell there, without going into too much detail there, our approach to securing some feedstock. The fact that we can extract high value, we have high black mass extraction rate, at the same time as high quality of plastic grade materials that are produced in a large scale environment, comfort the off-takers there that what they get as samples today will be representative of the future.
Ryan, you have your advanced hydro process. Can you tell us how that's different from other recycling processes, and how do you bring that to market? How do you convince OEMs to work with you to secure supply?
Definitely. So for our technology, much of my background and the team we've brought on recently is much more on the manufacturing side of battery cells. So we started off designing, some of the largest, battery factories in the world, at the Tesla Panasonic facility near Reno. That's where much of our team came from. And when you really work manufacturing battery cells, going from raw materials to refined powders, to slurries, to coated systems, to dried cells, to rolls, to modules, to packs, and you see each of those incremental stages, each one of those is really where you see these different types of defects come off, where you see different physics-based mechanisms of what actually causes each step in the manufacturing process to fail. And when we came to design a recycling system, we actually designed what we call a demanufacturing process. So using many of the tools that we developed on the cell manufacturing side, we're now essentially doing those in reverse and actually backing them out. It allows for a very automated and a very low residence time process to reverse that system. And then when we talk about hydrometallurgy, it's still a very large umbrella, a large set of technologies that fall within that family. And just because a few different systems are based in hydrometallurgy doesn't mean that they're at all similar. So by doing that reverse manufacturing process up front, we're able to remove a very large amount of the low-value materials, of the support materials, the sub-cell structures, and even separate out the sub-cell components that are chemically bonded together. And when we do that, the type of slurry and filter cake we get at the end is very targeted, already has very large amounts of the would-be impurities removed, and that's allowed us to put together a rather simplified hydrometallurgy train. So we've been able to remove entire impurity removal circuits that would have been needed otherwise, but because we're able to remove these components mechanically up front, it greatly simplifies that back end. And every time you have an impurity removal system, no matter how good it is, you always take a little bit of the product of value as well. So the fewer impurity removal systems there are, the higher the recovery ratio. And then as far as the cost of these types of recycling plants, they really do end up being dominated by the chemical consumables in the hydrometallurgy train. Large amounts of the acids, the caustics, the organics, the oxidizers that are consumed in the back end. And by having this targeted process, it really lets us reduce all of those chemical loadings, which reduces the operating costs of the plant and increases the recovery ratios of the high-value products.
Dawei, we talked a bit yesterday. What is the benefit to your customers of the spoke system?
Yeah, thank you, Kim. So our spoke system is very nimble. So we co-locate them with our customers, sometimes very close to them. So for example, that we have a spoke we just announced in Alabama. That's very close to a location that Mercedes is going to build their factories. Our spoke system, in a standard design, is about 5,000 metric ton battery sorting and processing capacity per year. The footprint for that, so the physical footprint for that is less than 10,000 square meters. And we can put 2 lines side by side to operate as well. And if you think about that, the advantage of that system is it can be very close to where the battery cells are being manufactured. So you minimize the transportation and packaging cost of moving the scrap batteries from the cell producers to the spoke to processing that. So that's a cost saving for our customers. And also you minimize and eliminate the transportation risks associated with transporting the scrap batteries. And also our process is primarily a mechanical process where it does not generate wastewater. It's ambient temperature process. It has very low air emission. So the environmental footprint is very friendly. So it's very easy to deploy that among the different parts of the country or in different parts of the world. So our philosophy is really to deploy the spoke systems that are to the different parts of the country in the world where we convert that to black mass. And so it's very easy to transport black mass to a centralized hydrometallurgical process to process that. So that's one thing that I think help us to scale up and build facilities in North America so fast.
It's interesting when you talk about where is the stream of recycled material coming from. We model a up and running, well-run cell plant with about an 8% reject rate. Some of the newer plants, when they shift from new technology to new technology, 111 to 532 to 622 to 811, they can have up to a 30% reject rate. A lot of the companies tell us, and I'm curious, Ryan, I'll start with you, they want to work with you because number one, if the cell manufacturer works with you, hopefully it's easier for you to recycle, but then as you said, maybe you can help them understand why they're seeing the defect rates they're seeing.
Definitely. When people say defect rate, a lot of times they think it means a final cell or a final pack that goes through a quality check, but it's each one of those nodes. So those numbers you're quoting, if you look at it just on a mass basis, it actually ends up being quite a bit higher as well. Different types of powders and slurries and scrap metals all become waste products. And a lot of those intermediate and maybe unconventional waste products are even harder for conventional companies to recycle. So those pile up on these sites and manufacturing facilities. They're not quite sure what to do with them. And again, by having a reverse manufacturing process, we don't simply mix all the materials together and put them in the front end. So when we have our module section dissecting down to the cell level, any defects we receive at the cell level, we feed into that intermediate feed stage where it's already in the partially deconstructed set. And then the same with the powders and slurries. We feed those towards the back end of our system where the recycling stream is already back down to powders and slurries. And you talk about switching chemistries, part people may overlook is really the type of qualification that's needed whenever a large chemistry change is made. So they're not necessarily defects, but there are hundreds of millions of cells that are made just for testing, just for characterization, to go through that qualification process that are never sold to market. So all of those need to be processed as well. And then the ability to take each of the elements we pull out and not just sell them back to a market, not just to the industrial market through a downcycling process, but actually to take them and purify them all the way back to battery cathode grade is not a trivial process. and then working closely with both the cell manufacturers and the step before them, the cathode refiners, to actually send these materials back to them in the exact form they need to really make that a true closed-loop economy and return that material right back into the system.
One of the more difficult aspects, I mean, I think a lot of people like to look first at the nickel and cobalt and lithium. Yves, you're doing some interesting stuff with graphite. Can you tell us a bit about your recycling of graphite, and can you tell us about the difficulties in recycling graphite, particularly if, say, you have one cell that's natural graphite and one that is, you know, a synthetic graphite, to recycle that and bring it back to the stream. Can you tell us what you're doing? I know you have a deal with Nouveau Monde.
Correct, yeah, with Nouveau Monde Graphite. And the reason why there are a lot of synergies between our two companies is that they have installed their first large-scale commercial line in Bécancour, Quebec, where they have the purification, spheronization, and coating of the graphite. And what we've done with them, we've developed a work protocol to send them a few different samples of graphite from our recycling process. And they will introduce that at various places under various conditions in their large-scale first commercial line, and determine what are the conditions for it to be recycled in new anodes. And also they're going to have some of their customers involved in testing that graphite to see how it can be reintroduced there in new anodes, as I mentioned there. So again, it's working at a large scale enough to be successful and to de-risk a commercialization. As you know, and as you mentioned, right, not too many people are working in that sense, but our holistic vision there is if it is possible there by teaming up with Nouveau Monde Graphite, they will find a way to make it happen.
You know, Dawei, one of the things you'll be responsible for in your new role here is to go to Asian markets. Some of them are probably very small in terms of the supply. And you talked about, can you tell us a bit about your mobile units and how that will be able to help you sort of move quickly into markets that are relatively small and developing?
Yeah. So I think you can, as I said, my role is to lead the market we have in Asia. I've been, I came from China. I've been living in the US for 13 years, but my plan is to move back to Asia next year. And we're building a team there. We're also working with partners in trying to grow our presence in Asia. So I think if we look at Asia, there are two markets really. One market is within China, which is a very big market. China right now, 40% of the batteries come from the manufacturing process, from cell producers, from the OEMs. 60% of the batteries are from the short end of life. So that's a very different market compared to what we see here in North America. And then outside China, you have the Asia, Japan, Korea, Southeast Asia, India, where the EV penetration is lower, and also the cell production is not as many as in China. So it's in terms of market size, it's a smaller market. So our approach, so we're in some conversations with our potential partners in Asia. And one thing I think they are looking for is essentially our spoke technology, where it has a really attractive environmental footprint. And that's going to be a key requirement for them to thinking about how to put that assets in place, because to getting that permitting outside China and even in China is going to be increasingly scrutinized. So our process helped them to having that pre-treatment capabilities in place to produce a black mass, and then we may be able to leverage the existing hydrometallurgical capacity in the region to process chemicals. So we're still developing our playbook in Asia, but I think the spokes model is going to be a key model for us to deploy that technology. In China, if you look around, they have a model where they're using primarily the producers over there, they're using a pyro process to making black mass. and then they are using existing hydrometallurgical reactions to convert the black mass to the primarily just the nickel and cobalt. So our spoke process, is not a pyro process, so that help us to be able to get the permitting in place and to place them in different parts of a large country. And also, our backend process, we are able to extract lithium as well. So that adds value because right now lithium price is coming up so much. So that's what we are doing, and I think that's our value proposition in Asia.
It is interesting, because it was thought pyro was the first way to recycle batteries, but the recoverabilities and the ESG footprint is just not acceptable, so it will be hydro. Ryan, you won the BASF competition. Can you tell us about where you think hydro is going and what the future is? As you said, there's not one hydro process, there's many. How do you think this will progress, and what's your approach to the best, hopefully, hydro solution?
Right, yes, it was great to win that competition. And when people think conventional hydrometallurgy, they usually think of solvent extraction. And that's a very mature process. There are new extractants being developed, but the technologies themselves are very mature. That's more of a low-risk approach. There are many different types of selective extraction, selective ion exchange type systems that can be much more targeted. And it really is about developing that network of components that fit together as circuits. Like I mentioned, having to have these types of impurity removal systems upstream of product removal systems adds cost upfront in CapEx, adds operating costs, and reduces your operational efficiency and your recovery ratios. So I think it really is the entire strategy of how you actually do that. And you mentioned the high-value components people think of, nickel, cobalt. Sometimes you're able to extract lithium. There are many other components in these trains. People think of things like the fluorine and the phosphorus species as contaminants, as impurities, but those elements are still needed to make new batteries. So you can remove them as an impurity in an inert or non-hazardous form. You can treat it as a waste, but there's much more value in actually extracting them as products and return them right back into the market, even though they may not be as high of unit cost as the nickel cobalt up front. So I think people who say, we're going to do a generic hydrometallurgy train or all hydro trains are similar, that's a bit shallow of a statement. It's really about designing this as an integrated network and having it work with that strategy to balance the operating costs with your recovery efficiencies and not just going for the high value components. And you mentioned lithium specifically. Lithium is challenging to recover in a recycling system because it's designed to be the mobile ion within a battery. So it's literally in every component. So when you start disassembling and sorting, you can segregate different elements relatively easily, but lithium itself is really in all of those components. So it's not just be able to recover some of it, not just the aqueous lithium, not just what was dissolved in the non-aqueous solvent, what was embedded in the active anode and the cathode, and really getting to a process where you can recover not just the primary streams, but the side streams, the recovery streams. Those are really how you get to the much higher recovery rates for all of these ions of value.
It's what you target. Well, often in these early stages, you target cobalt, or you target the nickel, or you target lithium, but then there's other parts of the stream that you miss out, and trying to get everything is going to be challenging.
And even the mainstream, like I mentioned, there are many side streams that are developed as you start taking these other products off. And going after those side streams and additional recovery is really how you get to those high recovery rates.
And Yves, you target set 95% of the lithium ion components. Can you tell us which of the components you're getting, which ones, what's left in the 5% that are more difficult to go after?
Well, I would say that basically we recover the cathode materials and the graphite at a high rate. And when we measure 95% recovery, of course, there are recirculation loops there, so that 5% is not necessarily lost. It's just recycled, let's say, at the leaching part there, and it stays in the system, and at the equilibrium there, you will get more recovery. So one of the streams that we're working on is the small quantity of aluminum and copper that ends up in your hydromet that you can fairly easily extract. And then the idea there is to valorize it as low as possible of a cost to increase your overall cost effectiveness. So that's how we work with the demo plan there, optimizing each step of the process, and then getting the engineering data there that will minimize that are minimizing the scale-up risk to commercial operations.
I'm just curious, it just popped into my head. Number one, how do you recycle the separator? And two, a lot of this conference has been talking about solid-state batteries. How will you work with these new chemistries with novel components to recycle those? I'll open that up to anybody.
Yeah, well, I think I mentioned it there in my intro there. Part of our business plan is also to build a technology center. And that is part of our first, that will be built in parallel to our first shredding operation. And the idea behind that, Ken, and the audience there is exactly what you mentioned, Ken, is that the chemistry of the battery will evolve and will continue to evolve. You talk about solid state there, we're already looking into it. The other thing that will keep on also changing is the purity and the impurity profile of the cathode materials that people want to have purer and purer, with as narrow as possible of a variation to be able to reuse them seamlessly into new cathode manufacturing. So our technology center there will focus on these two aspects to make sure that we stay current, and that as much as our first operation and our licensees will have access to technologies that will allow us and them to recycle cost efficiently their current chemistries and future chemistries.
Can you recycle the separator?
Separator ends up into the plastic stream. Currently, we haven't put a focus on that. We have a side project on it, but again, there we're not focusing on it now.
Ryan, can you go after that?
So recover separator, yes. So recover it as a separate stream that can be sold into the plastic recycling market itself. So again, I mentioned taking an element and turning it back around directly to make brand new batteries is very important for a closed loop economy. Right now, the separator goes through a much longer chain. So we can recover it, we sell to plastic recyclers, which then make more precursor for the plastic process, which you eventually get back in. So it goes through some external processors, but overall, yes.
Can you tell us your philosophy on open loop, closed loop, and how to close the loop?
I mean, many people look at closing the loop. I always view it kind of in the carrot and stick approach. There are a lot of policies that are meant to punish companies who don't recycle batteries or individuals who don't, or try to force a minimum amount of recycled content into materials. For some industries, maybe you need to do that, but for this industry, I think the carrot works much better. The fact that there's so much value left in these end-of-life and defect materials. Many recycling processes to date haven't been efficient enough to be able to operate at sufficient margin to recover those with real value. But as these new technologies come online, if you can operate a high-margin facility and recover these materials, and especially in areas like the US and North America, where there's almost zero production of these battery metals. The lithium, nickel, cobalt, manganese, each of those four, less than 1% of global capacity is in the US. So having an end-of-life battery can essentially be the perfect mine to recover each of those elements in the exact ratio needed. And if you have processes that can really recover them back up to the battery cathode grade specifications and return them right back into the market in North America, that's how you close the loop. And it doesn't have to be necessarily regulated, because the economic incentives are already there if there are recycling processes that are efficient enough to operate without having those external forces needed.
I know we broke down a whole bunch of battery cells from China, and we sent them to a university we were working with in Brussels, and just getting the cells there was a huge problem because of regulations. Dawei, curious how you are dealing with, I actually think one day the cars, when they're done, they're going to drive themselves to the recycling plants. I actually think that really is going to be the way it will work. But until then, you have the cells, you have the cars. Once you take those cells out of the car, they're considered basically a bomb. How does Li-Cycle look at that, and what is your advantage to your processes?
So again, I think our philosophy is, excuse me, it's much easier to transport the black mass than to transport the batteries. So that's why, our model is to put the spokes close to where the recycled batteries may be. In terms of the transportation and packaging in the U.S., I think right now the scrap batteries is categorized as Class 9 hazmat. The transportation is not that requirements is not stringent. However, it's the packaging that's needed to make sure that when we are taking the batteries from the cell makers to our spoke, that it's being transported in a safely manner. So we do make sure that we have the packaging material in place to do that. However, our spoke process, the model we're trying to do is you co-locate the spoke process with the cell manufacturers. So if you do that, you're really minimizing the transportation cost and also the packaging cost that you have to otherwise incur by transporting the batteries. So when you transport the black mass, that hazard is not there. So it's much easier to transport black mass to a centrally located hydromet process to producing chemicals. So if you look at what's happening in China right now, there are several producers that are recycling the batteries right now, producing chemicals, and we see that really they're viewing the scrap batteries as a resource to supplement the primary metals that they use to produce the precursors and also the cathode. And so what's important not only is to having access to those resources, but also to having a very cost-efficient logistic and supply chain to making sure they are in place to transport those to the place. So having access to having a network that to effectively minimize the transportation cost and having access to the resource that's coming either from the end of life or from the manufacturing, scrap process. Those are important criteria, for a recycler to be successful.
We have about 10 minutes left. Are there any questions here or online? Nothing online. Any questions in the room?
If I just add your last question maybe about why we want to move to a closed loop economy versus why we want to minimize transport, they really are related. I mean, right now what exists is mostly a lot of these materials being made in the Asian market and transported kind of one way to North America and Europe. But the whole point of a closed loop economy is that these elements are never consumed. So if you really can establish each of those groups to make a closed loop economy per region, then you never really have to be doing these transcontinental shipments anymore. If you go all the way from recycling through the metal refining, through cell manufacturing to vehicle manufacturing and back around, each region can have that network, which really makes this much more localized. So that helps from the transportation side, it helps from the cost side, really not having to transport those long distances, and then also just from the security of supply, knowing that once a material is in a region, it can be used indefinitely in that closed loop, really reduces those security risks, both for the corporate level and the government level as far as national security.
Yeah, and I would add to that also, it also reduces the carbon footprint rather than having long supply chain there, as Ken and your team there know better than Noel there and published on that there. I mean, it doesn't make real sense there. If you look at the consumer pressure there for ESG social responsibility and reducing carbon footprint, on the one hand, there the cell and battery manufacturers and OEMs have pledges for that. And at the same time, as Ryan mentioned there is the security of supply, but also the carbon footprint involved in here, in having basically that worldwide market where it crosses the ocean a couple of times before it gets into a new battery doesn't really make sense,
Yeah, I mean, it's when we talk to automotive OEMs, they're asking us for carbon footprints for every metal. They understand that they will be taxed probably, we think, around 2027 on the carbon content. I think the way we have figured it out, recycling probably reduces that carbon footprint 40 to 60%. And so it will be, as you say, it's a huge economic advantage rather than just being a good steward. It's also going to be the best way to do things.
Yeah.
Quick question here as we're getting towards the end of this. Yves, can you tell us a little bit about your first commercial plant? It's going to be launched 2022, 2023. Where are you in that process?
We're finalizing the financial agreement for that and our technology center. And we shall be able to launch construction at the end of this year, or about 9 to 12 month time to construct and to commissioning. First, yeah, go ahead.
And the size of that plant would be?
7,500 metric tons of feedstock, either batteries or production scraps. And it will be located in the Montreal area in Canada. And as I mentioned there, we're already in discussion with licensees there, people already involved into the lead acid battery recycling, having contacts, having buildings, having logistic streams already in place, just missing the right technology to safely recycle the lithium-ion batteries. So that's what we're going to be providing them with.
Ryan, your path to market?
So we're currently building our first pre-commercial pilot facility. So it's a throughput of 20,000 metric tons per year. It includes both the front end of our process, that mechanical demanufacturing, and also the back end, our hydrometallurgy train, right, in one facility. So we're building this in northern Nevada. We've received the majority of our permits to start construction. We've hired our construction firm and finished the design of the full plant. And we'll be breaking ground any day now as we hear back on the last permit.
Awesome.
And like I mentioned, we also have our primary lithium extraction system. So we were fortunate enough to just win a Department of Energy grant a few months ago, working with DuPont on this process. So we're building a 5 metric ton per day field demonstration system in central Nevada for our primary lithium extraction system that we're building in parallel with our recycling plant.
And that is DLE?
It is not DLE. It's a selective leaching type process that we've established that really moves that selectivity one step up in the process flow sheet, which then allows for a much more simplified leach liquor generated. And then a few different steps about how we actually make our lithium sulfate and convert it to a final hydroxide cathode grade product.
Interesting. And Dawei, where are you on your commercialization project and what expansion plans do you have?
Yeah, so we have announced 4 spokes in North America. Our hydromat hub process is being, we're going to start construction by end of this year. And we're targeting to commission the plant in first quarter of 2023. The equivalent capacity for that hub is to process about 60,000 metric ton battery per year. And we're building our spokes, which are the front end pre-treatment plants, for locations of North America to supply the feedstock to that hub process. We also have plans to expand in Europe and also in Asia Pacific, which I think announcements will be made in the future.
Any questions before we have our last round here? There's a lot of companies looking at the recycling area, a lot. What do you think the future will be in terms of this industry? Do you think it will be many, many smaller players, or do you think one technology sort of wins out and becomes the dominant area? Ryan, you're the big thinker here. Do you think it will be many different processes for many different parts of the world, or how do you sort of see this industry 10 or 15 years from now?
I don't think there will be a technology that's a winner because the chemistry of batteries is not fixed. There's not a winner on the battery side. It's dramatic amounts of R&D going into the battery manufacturing side, and as that keeps improving, the recycling industry has to keep improving with it. And that's why these have to be dynamic facilities. I mean, as far as who's actually going to be the winner, I think it really comes back to this closed loop economy and the fact that these elements are never consumed if they're handled correctly. So what I really see happening is these types of partnerships or alliances or consortia between companies in each of those different groups of the circular economy. If you have a battery recycler and a primary metal extraction company with a cathode company and other metal refiners and a cell company and a vehicle company working together, you can essentially own that material indefinitely. You can own that supply chain. You can really work to be independent from the rest of the market. You can have almost indefinite security of supply by having access to those materials going forward. So I think it's those alliances being formed and whoever can form the best partnerships to really make that happen at the commercial scale. And then even beyond just the products and market, you have your R&D divisions between the recyclers, the cathode companies, the cell manufacturers, working together on the next generation of material of what's up the pipeline. So you're not just waiting to see what happens to get to market. So I really see that as the key to going forward, is locking down those relationships with the large players to form those consortia.
And in terms of consortium, Yves, the Canadian market is going to be different than the U.S. market, then is going to be different than the Indian market, et cetera, et cetera. You're a leader in Canada. Do you see this as a regionalized area or a bunch of strategic alliances? How do you think it works out?
Well, I mean, if you look in Quebec, there's advantages there, especially on the hydromet, because our energy source there is 97% hydroelectricity. So that's a big advantage there. And when you think about the logistic chain between Canada and US, I mean, 65, 70% of manufacturing goods are exported into the US as we speak now, generally speaking. So it's a very short supply chain. With regards to who will win at the end, with the volume, and Ken, you've done the math there, with the expected volume there, we believe there that there will be more than one winners. Ryan spoke about the alliances there and having multiple people in the chain involved working together. I'm of the same opinion there, is that nobody will be able to do it on their own. There will need to be all the players involved into the full recycling process back to manufacturing new batteries with these recycled material, and that's how in our vision there will be the winning, I would say, a winning scheme. Now, with the volumes in place, I'm repeating myself here, but there will be more than one winner.
Well, and that's, I guess, the purpose of conferences like this, is to bring together a lot of people so that we can start to build the system globally to really do this. So our timer has gone off. I'd like to thank our panelists here and Yves on the internet, and thank everyone for attending.
Well, thanks to everybody there. Nice being on that panel there, and thanks Ken there for the great leadership and great questions.
Yes, thank you all so much. And up next,
Bye-bye.
Thank you. Up next is Dean Frankel, who will join us for a presentation. Thank you.